Welcome to lesson 5.5 of Math 20-1, where we are going to start solving rational equations. It's going to be exciting, people. So the difference between today and all the other days in this unit is we are now going from rational expressions to equations. So what the heck is the difference between an expression and an equation, Mr. Kennedy? Well, that's a great question, Mr. Kennedy. The difference is that an expression has no equal sign. So if you were to look back at all the previous questions we had, they always started without an equal sign, and we were simplifying. We were just manipulating the expression. Now we're going to have equations. Equations have equal signs. This means that all of our questions should actually finish off as x equals something, and we'll really be finding values for x that makes the equation true. Should be pretty thrilling stuff. It's actually going to be a little easier than 5.4, in my opinion. Let's just jump into it. So we're going to skip this. This is solving linear equations. Don't need to stress it. We're going to come all the way down to this guy. So let's start it off. We got this question right here. I instantly know I am actually solving for x because there's an equal sign. That means my question should end as x equals a number. Perfect. The steps to solving are the same steps that we had for simplifying. So the first thing you always do is factor. This obviously can't be factored because everything is a monomial. The second step is state your non-permissible values. Again, things that cause you to divide by 0. My non-permissible values would be x cannot equal 0 in this question. Now we move on to third step. Third step has always been simplify. In this case, it'll now be solve. So to solve something, you need to get a common denominator, just like in lesson 5.4, just like in lesson 5.3. So let's get a common denominator. Now I have 2, 4, and 4. They could all become 4 if I just multiply that one by 2. Let's look at our letters. This one has x, this one has no x, and this one has an x. So this one needs to be multiplied by x top and bottom. Okay, let's write out what we got. This means I have 10 over 4x plus 3x over 4x equals 9 over 4x. Perfect. Common denominator achieved. Now, normally, on previous questions, once you got a common denominator, your goal would be then to write everything together into one nice little fraction. But when there's an equal sign in the question, we can do something different. What we can do is we can take this 4x and we could multiply it to the other side. And when you multiply it to the other side, it will go to every term. And the beauty of multiplying everything by 4x and having a common denominator is that your denominators are all going to cancel out. And you're going to be left with 10 plus 3x equals 9. How beautiful is that thing, right? That is now an equation. I'm like, I can solve that. That's a linear equation. Boom, let's go solve it. So what we did was we got a common denominator, multiplied everything by 4x so that all the denominators got canceled. Essentially, we've created a rule that you're going to hear me say in the future. And that rule is, if you have a common denominator and an equal sign, the denominators go away. So every time you get a common denominator and you have an equal sign, boom, cancel out the entire bottom of the question and just work with the top. To solve the top, this is a linear equation. That means we need to get x by itself. So I move my 10 over. That gives me 3x equals negative 1. And then I divide by 3. And this tells me that the value of x that makes this equation true is negative 1 over 3. Ta-da! That is solving rational expressions. So wonderful. Okay, let's try another one over here. So, first things first, we want to factor. Can't factor. Second thing, state your NPVs. Your NPV here is x cannot equal 0. Perfect. Third step, you need to get a common denominator. This one sometimes tricks people. So the reason it tricks people is because of this 3. And people don't view that 3 as a fraction. So it's very important that right off the bat, go and turn it into a fraction so that you realize it also needs a common denominator. Now when we get that common denominator, this one needs to be multiplied by x. This one needs to be multiplied by x squared. That will give me x squared on the bottom of every single question. So I now have 3x squared divided by x squared plus x divided by x squared equals 4 divided by x squared. And we can use our newfound trick, which is once you have a common denominator and an equal sign, the denominators go away. And all you have left is 3x squared plus x equals 4. That thing you can now solve. This is a quadratic equation. Highest exponent is 2. Quadratic equations have to be in general form. So this becomes 3x squared plus x minus 4 equals 0. We solve this using box method, quad formula, or factoring. I'm going to try to factor it. So if I wanted to factor this thing, I'm going to multiply to be negative 12 and add to be 1. That would be 4 and negative 3. So this becomes 3x plus 4, 3x minus 3. One of these 3's has to go away. It's the second one that has to go away. That gives me 3x plus 4, x minus 1 equals 0. To finish this question off, because I've now factored it, it's still equal to 0, so I need to find the values that would make this true. So looking at my first binomial, my answer would be x equals negative 4 divided by 3. The second one right here would be x equals 1. So I have two solutions to this question. It's x equals negative 4 over 3 and x equals positive 1. That is solving equations. It honestly doesn't get that much crazier. The only way it's going to get crazier is maybe some harder quadratics to solve at the end. Okay, let's move on with our lives. I mean, just in math. So there's two questions here. I want you to try both of them. Pause the video, give it a try, come back and check out the answer. Okay, welcome back. Hopefully you did those questions. My answer for the first one is x equals 1. The answer for the second one is x equals 3 over 2 or negative 2 over 3. If you did decimal 1.5, that's fine. I'm going to run through how to solve them quick. So if you look at this one, my first step was factor. Couldn't factor. I did state my non-personal value. It's up here at the top. And then I got a common denominator by multiplying everything to become 10x. I use my nice little fancy rule. Common denominator and an equal sign gets rid of the denominators. I was left with a linear equation. 5 minus 4x equals 1. I subtracted my 5 over. 1 minus 5 is negative 4. Do make sure that you have this negative still, right? Sometimes that disappears on people. That's a negative 4 you have to divide to the other side, giving you a final answer of x equals positive 1. Pop on over to the right side. First thing I did was I turned this 6 into a fraction, right? I was like, okay, I need to make that divide by 1 so that I know to get a common denominator. Get my common denominator. Everything is now divided by x squared. I can therefore cancel out my common denominators because there's an equal sign in the question. I moved everything to the right. This is a quadratic equation. Remember when you're solving quadratics, you want a positive a value. So because this is a positive 6x squared, I wanted to keep that thing positive. So I moved the 5x and the 6 to the right so that my a value stayed positive, right? That's important when you're factoring. I could factor this, so things that multiply to be negative 36 and add to be negative 5 would be negative 9 and 4. I write out my binomials. I have to somehow divide a 6 out. I had to do it in chunks this time, so the first one by 3, the second one by 2, giving me this final answer, which was 2x minus 3, 3x plus 2. Solve my binomials. The first binomial is 3 over 2. Second binomial is negative 2 over 3. All right. You are crushing rational equations. This, if you want to mess around with your calculator and learn how to check your answer, you can. Essentially, what this is doing is giving you instructions on how to tell your calculator what x equals and then putting it into the function to see if it actually worked out or not. It's like just checking your work. Okay, we got a couple questions here I'm going to do with you. Then you're going to do a couple on your own down here. And then we will have one hard one. So let's look at this. First things first, we want to factor. In my factoring step, remember to put brackets around binomials so that I remember things are paired up. Second step is state my non-principal values. My non-principal values come from those denominators. My non-principal values x cannot equal negative 4 or positive 2 because that would cause me to divide by 0. Now that I've done all that, I get to my simplify/solving step. I need a common denominator. This x plus 4 needs to be multiplied over here. What you do to the bottom, you do to the top. This x minus 2 needs to be over here. What you do to the bottom, you do to the top. And we see here that we now have a common denominator, so we can cross out our common denominator, and all we have left is 5 times x minus 2 equals 3 times x plus 4. Currently, I don't know the type of equation I have, and I need to solve it. So in order to do that, you need to expand. Multiply the 5 in, multiply the 3 in. And then we will know the type of equation we're working with, and then we can move things to where we need them to be. So this becomes 5x minus 10. This becomes 3x plus 4. This is a linear equation because the highest exponent is 1. I solve linear equations by moving my x's to the same side. So I subtract my 3x over there. That gives me 2x minus 10 equals 4. I need to add my 10 to the other side. That gives me 2x equals 14. And then I divide both sides by 2 to get my final answer of x equals 7. Cool. The beauty of rational expressions is you can verify your answer. So if you go back to the original question, you could verify your answer by going back to the original equation and changing x to be 7. So instead of x plus 4, make it 7 plus 4. Instead of 3 divided by x minus 2, make it 7 minus 2. And then put both things in your calculator and see what happens. So I have 5 divided by 11 here equals 3 divided by 5. And if you put those in the calculator, it actually doesn't work. So that tells me that somewhere in this question, I've made a mistake, right? 5 divided by 11 is 0.45. 3 divided by 5 is 0.6. That is not the same. So we've made a mistake somewhere. If I go back and I look at my work, and I try to look step by step to see what I did wrong. First step was I got a common denominator. That worked out well by the looks of it. I then canceled my common denominator. I think that's right. I then had 5 times x minus 2, 3 times x plus 4. That is definitely right. I then multiplied in. 5x came in to become 5x minus 10. 3x came in to become 3x plus 4. Wait a minute. That's not right. 3 times 4 should have been 12. So you can go back to your question and fix your work. This should have been a 12. That means that this should have been a 12. That means this should have been 12 plus 10, which is 22. That means this should have been x equals 11. And now you can go back and try to verify that solution. So instead of saying x equals 7, let's go back and change it to be 11 and see if this actually works out. I put 11 in for x. That gives me 5 divided by 15. That gives me 3 divided by 9. 5 divided by 15 in your calculator is 0.3 repeated. 3 divided by 9 in your calculator is 0.3 repeated. The mistake is now gone. I know that this is a correct solution. One of the most beautiful parts of this unit is that you can always verify, I shouldn't say always, you can almost always verify your work. And there's going to be so many simple mistakes in this unit, from just multiplying and adding and subtracting. So verifying your solution takes a couple seconds, and it'll tell you if you're right or wrong. You can then go back and fix your mistake. If you can't find your mistake, I would restart the question, because you probably won't make the same mistake twice. So if I couldn't have found that I made this error on my 12, then I would go back and just restart the question from the beginning. Cool. Let's try another question. So first step is always factor, and people start to take that for granted by this point in the unit, because a lot of the times you don't have to factor, but there are occasions where you do, and this is one of them. This is a square rootable binomial, so you need to factor that to become x plus 1, x minus 1. Over here, nothing can factor, but I am still going to put brackets around my x plus 1. Gorgeous. Then I have to state my non-principal values. Also something that people will start to take granted because they haven't had to really use it much and they forget to do it. So in this case, x cannot equal positive 1 or negative 1. Cool. Now we can start to solve, but those first two steps always have to happen. I need to get a common denominator. This one's missing an x minus 1, so I multiply the top and the bottom by x minus 1. My denominators are now the same, so I can cross them out, and I have 3x plus 1 equals, I'm going to multiply this negative x into the brackets to become negative x squared plus x. This is a quadratic. To solve quadratics, I have to equal 0. I also want a positive a value, so I'm going to add x squared to both sides. I'm going to minus x from both sides to give me x squared plus 2x plus 1 equals 0. Once I'm in general form, I can factor. This thing does multiply to be 1 and add to be 2. It'd be 1 and 1. So this factors out to be x plus 1. Uh-oh, internet's going down. It's going down! Look at this madness. Oh no, it's falling apart. Come on, computer. I don't even know if this is recording my voice anymore. X plus 1, or x plus 1. We can get through this together, people. Equals 0. Okay, we're almost there. So we factored that thing. Now I look at my binomials and I say, okay, this one would be x equals negative 1. And this is the exact same, so I don't need to write x equals negative 1 twice. My solution is x equals negative 1. However, something new is happening, and it has to do with our friend the NPVs. NPVs tell you what x cannot equal. I have a contradiction here. I'm saying x cannot equal -1. Then I'm saying, hey, x equals -1. The NPV overrules whatever you solved. So this solution is wrong. And that means there is no solution. Remember, our term was that's an extraneous answer. So x equals -1 is extraneous. Now, for the record, you have to show that x equals -1 was the correct answer, and then you have to decline it and put an x through it. So just a reminder that you have to show me you knew it existed, and then show me it's wrong by putting an x through it, and then writing no solution. Cool. What this means is that there's no value of x that would ever make this original question up here true. Those two fractions could never actually equal each other. Cool. Your turn. 2 questions right there. Rip through them, pause the video. When you come back, all of a sudden everything will be solved for you. All right. Hopefully you just unpause the video after you finished all your work. We'll look at the first one first. So I have to factor. There is no factoring, but I do put brackets around my binomials, okay? We definitely want that so that I remember things are package deals, right? Then I state my NPVs. I did it at the top. X cannot equal -2 and 3. Make sure you write those out somewhere. Then I got a common denominator. I multiplied the first one by x minus 3, the second one by x plus 2, and I canceled out the denominators because there's an equal sign in the question. I then got this little equation here, which I expanded. When I expanded, it gave me a quadratic function. I had to make that quadratic function equal 0, so I moved everything to the right. That gave me something I could factor. So when I factored that, I got 2x plus 9, 2x minus 2. One of the 2's had to go away, so I divided the second one by 2 to get my final factoring right here. The answer is -9 over 2 and +1. If we look at the second question, first step is factor. I put brackets around my binomials so that I knew it was there. I then multiplied the first fraction by x minus 1, the second fraction by x minus 5. I then had to expand, right, because I got rid of my denominators. When I expanded, I got x squared plus 2x minus x, and I got x squared minus 5x. I noticed this was a quadratic, so I started moving everything to the left. But when I moved everything to the left, the x squares actually canceled each other out. So I was left with 2 plus 5 minus 1 equals 6x. So I had 6x minus 2 equals 0, move the 2 over, divide by 6, and I got my answer of x equals 2 over 6. All 3 of these things are the same, right? I would accept any of those answers. One's as a decimal, the other 2's are fractions, one's just a simpler fraction. Awesome. Hopefully, this is going smooth for you. Let's jump down here. If the computer will let me. We'll do the one on the left together. The one on the right will be practice for you. Then we won't do this question. You can try it if you want. Okay. Let's look at this. First step to every question in this unit is factor. This one can factor. That x minus 3 can't, but I'll put brackets around it. Equals -6 divided by, if I do a diamond method on that thing, things that multiply to be 15 and add to be -8 would be -5 and -3. So this factors to be x minus 3, x minus 5. Awesome. Second step. State what x cannot equal, your non-permissible values. My non-permissible values for this question would be +3 and +5. I'm losing the internet again. No! No! I have no idea what's being written on the screen right now. I don't know if you can hear me. If you can hear me, send help. Oh my gosh, what just happened over there? Send help to H.J. Cody. Mr. Kennedy's in dire need. Bring pizza. Okay, let's try that again. So my NPVs would be x cannot equal 3 or 5. Cool. Now we can start solving. To solve, I need to get a common denominator. They both already have an x minus 3. This x minus 5, I need to get to the other side. Because I have a common denominator and an equal sign, remember that has to be there, I can cross off my bottoms. So I have x times x minus 5 equals negative 6. I multiply the x in, I get x squared minus 5x equals negative 6. I add my 6 to the other side, I get x squared minus 5x plus 6 equals 0. I now need to try to factor that to solve it, because quadratics you solve by factoring. Things that multiply to be 6 and add to be negative 5 would be negative 3 and negative 2. So this becomes x minus 3, x minus 2 equals 0. That means my answers are x equals 3 and x equals 2. If you look at your NPVs, we have a problem. We said x cannot equal 3. Now we're saying it does equal 3. That is a contradiction. You can't contradict your NPV. This is an extraneous solution. So put an x through it so that you're denying it and you're saying, no, I know that's wrong. And then put a box around your good answer. There you go. The second question is all for you to try, and my internet is completely going down. So I'm going to pause, and then hopefully I can get through the explanation of this. So you go ahead and try your best. All right, let's hope that the internet holds up here and we get through this. So, where did the first one? Second one. First step was factor. I also remember put brackets around my binomials I couldn't factor so that I had them written out properly. I could factor that trinomial. It became x minus 4, x plus 1. I then worked to get a common denominator. Oh, sorry, I stated my NPVs. Right, I'm always rating those NPVs, usually at the top of the page up here. Then I got a common denominator. The first one needed an x minus 4. The second fraction needed an x plus 1. The third fraction was fine the way it was. Because I got a common denominator, I could cancel out the entire denominator. I then had to expand, and I want to make sure that you kept track of your negative. This negative symbol is like a negative 1 out front. So you have to multiply the two binomials together and then change all the symbols. So that's what I'm trying to show you here with that green arrow coming into my blue part of my equation. I'm showing you that all of these symbols had to change. So this became a negative x squared. This became a negative 2x. This became a negative 1 because that negative affected everything to the right. Awesome. Then I realized I had a quadratic. I had collected my like terms. The x squares canceled out. So now I actually had a linear equation. I moved the 1 over. I divided by negative 6. And I got x equals negative 1, which is a contradiction to what we had up here as our NPVs. So because it's a contradiction, I have to decline that answer. I put an x through it, basically saying it's a garbage answer. It's an extraneous root. And then I put no solution as my final answer. Awesome. That is solving rational equations. Yeah, we'll do some word problems the next day, and then we're going to start doing some graphs and stuff. So take care of yourselves. I hope to talk to you soon. See ya.